All right, we're going to continue working on binomials and trinomials and the such. Today our main objective is to find the square of a binomial and to find the product of a sum and difference. So let's talk about our essential understanding. There are special rules you can use to simplify the square of a binomial or the product of the sum of the and difference. And we're going to be looking at those special rules today. Squares of binomials, okay, so you're going to be hearing that term a lot. Squares of binomials have this form. So they show up like this, a plus b squared or a minus b squared. You can algebraically simplify the product, or you can use an area model to discover the rule for simplifying this. Now, so what we're going to do right now is we're going to kind of just discover it. We're going to talk about why this works. Why a plus b squared is equal to a plus b times a plus b. We're just kind of look at that and investigate it. Once you get familiar with it, then you'll just skip right to some of the rules that we're capturing today. So a plus b squared is a plus b times a plus b. That's the squaring. And then if we do the FOIL method, we can see a times a, which is a squared. We can see o, which is a times b. And then we can see my inner, which is b times a. And then we can see the outer, which is b times b, which is my b squared. And then I combine like terms, and that's why I end up with my two ab's. So I end up with a squared plus 2ab plus b squared. And this shows me that a plus b squared is equal to a squared plus 2ab's plus b squared. And this right here will be something that we get really comfortable with, really familiar with, so that when we see this, we recognize this side of it, or when we see the left side, we recognize the right side of it. So let's talk a little bit more about it. Here's the key concept when it comes to squaring binomials. The square of binomial is the square of the first term, done, plus twice the product of the two terms, done, plus the square of the last term. So we have two squares going on. We're squaring the first term and we're squaring the last term. And we can see that happening like in this first part. We're squaring a, which shows up right there, and we're squaring b, which shows up right there. You can see it on the second one. We're squaring a, which is right there, and we're squaring b, which is right there. Okay, but that middle part right here, where it says plus twice the product of the two terms. Okay, so I'm going to take a and b, multiply them together, and I'm going to double it. I'm going to take a and b, multiply them together, so a times negative b, that's why I end up with my negative ab, and I'm going to double it. Now let's look at it with like numbers and some variables. So let's play this out as we look at some more examples. So as I look at, again, how I'm squaring a binomial, I square my first term, I square my second term, 4 squared is 16, and then when I do my middle, I'm going to take the product, which is 4x, and I'm going to double it. And that's why I end up with 8x. Let's look at another example. Okay, I'm going to square the first term, so x squared. I'm going to square the last term, which is negative 3. Okay, so it's squaring that negative 3, which is getting to be 9. And then I'm going to find the product of these two together, so it's negative 3x, and I'm going to double it. So 2 times negative 3x is negative 6x. So I'm squaring my first term, I'm squaring my second term, and for the middle, I am doing twice the product of those two terms. So let's try this out on this guy. All right, so I'm going to square my first term, so which is going to be x squared, and I'm going to do the product. I'm going to do double the product of the two terms, so 8x, and then I'm going to square the last term. And I'm going to take this, and I want to simplify it a little bit more. I end up with x squared plus 16x plus 64. And that's the squaring of that binomial. Let's look at the second one here. Now I'm going to square the first term. So I end up with 4m squared. And then I'm going to double the product of the next term. So I have my negative 3 times 2m, so that's negative 6m. And then I'm going to square the last term. So negative 3 times negative 3 is 9. I'm going to simplify this. So I end up with 4m squared minus 12m plus 9. All right, why don't you give it a try? Why don't you square the a, and we use square b. All right, this is how these worked out, simplifying. Squared the first term, squared the last term, and I took double the product of the middle terms. So negative 7 times n is negative 7n, doubled is negative 14n. Same thing over here. 2x times n is 18x, and I'm doubling it to get me to the 36x. So let's go ahead and apply the squaring of binomials. It's just not something we do, but it does show up. A square outdoor patio surrounded by a brick walkway is shown. What is the area of that walkway? So first of all, we have to find the total area of the patio and that walkway. So the area of that is, let's look at a few pieces here. We know that this area right here is x plus 6. Because I've got my 3 feet and my 3 feet plus my x that's happening, and this side over here is also x plus 6. So I know that the area of the patio is going to be x plus 6 squared. X plus 6 times x plus 6. This is a binomial, so I'm squaring it, so I can use what I just did. I'm going to square my first term. I'm going to use double the product of my middle term, and then I'm going to square the last term. Simplify that. X squared plus 12x plus 36. Now we got to find the area of the patio. So we find the total area of the patio, and then yeah, that gets us set right here. So the area of the patio looks like it is x by x. So the area of the patio is x squared. So to find the area of the walkway, we need to take the total area, which we can see is x squared plus 12x plus 36, and I need to subtract out the patio area, and I can take my two like terms, clean that out, and I can see that the area of that walkway is what I've left, 12x plus 36. So to do this problem, I had to combine like terms, I had to square binomial, I had to keep track of my variables, and even the picture itself and finding those areas. So you're going to do the same thing, same concept, brick walkway, finding that area. But this one, the brick walkway is 4 feet wide. So let's see if we can draw that out a little bit. So you know in this drawing that it is still x by x, but with the walkway is 4. So we know that the area, or the distance from here to here is x plus 8. Press pause, you give it a try. All right, this is what happened. I found my squared by binomial to find the entire square, the bigger square, and I subtracted, that's the whole square, and then I subtracted out the inner square to get my answer to be 16x plus 64 square feet. You could also use mental math to find like the square of a number. So maybe 39 squared is something that we don't know right away, but we can look at it as 40 minus 1 to get to my 39 squared. And then I have a binomial here, so I can factor this out. Actually, I don't want to factor this out. I want to square it. So let's go ahead and square it. So I'm going to square the first term, plus I'm going to double the product of the second term, which is 40 times 1, which is 40. And then I'm going to square the last term. So that would be negative 1 times negative 1. So actually, we actually have 1 on that one. Now, I can combine these out. So I end up with 1600 plus 80. I lost track of a negative in here. Something has gone awry. Let me see if I can figure out what that is. Right here. Oh, the product. There it is. Like this should be going down. So the product of 40 times 1, there's my negative, and there's my negative. There we go. And then if I combine all these different pieces together, I can see that I've got 1521. Now this is just a method you can use. I know you're going to be itching to use your calculator on this one, but that's a method you can use. You can use squaring binomials to find a square that you're less familiar with, to work with ones that maybe you're more familiar with. The product and the sum and the difference of the same two terms also produces a pattern. So for all these, we're continuing to look for patterns. So let's look at this one. So we have a plus b times a minus b, and that shows up just like this. So I'm squaring the first term, so this would be like a FOIL method. So a times a, which is a squared, outside a times negative b, so that's why I end up with my negative ab, inside b times a, right here, and then my last term is b times negative b, so it's negative b squared. These cancel out, so it's simplified to this. So that's why we can say that down here that a plus b times a minus b gives me a squared minus b squared. And this is something that will get familiar with. We'll see it enough that it'll just become natural, part of what you're doing. So here's an example. We can see x plus 2 times x minus 2. And if we use our similar format that we saw over here, we can see it's our first term squared, which is x squared. And then it is our subtraction, I can see there, and it's of squaring our second term, which is 2 squared. So it simplifies out to x squared minus 4. And again, this is just something that we can practice out a little bit more and just see that whenever we are doing the product of the sum and difference of the same two terms, and that's real key, they need to be the same two terms being multiplied together. When that happens, we know that these middle pieces will be canceling themselves out. And our result will be the first term squared minus the second term squared. We're going to try it out. Finding the product of the sum and the difference. What is a simple form of x to the third plus 8, x to the third minus 8? Now notice what we're doing. We got the same terms, but this one's being added and this one's being subtracted. So let's think about the original product here. Okay. Identify which terms corresponded to the a and b in that rule that we were doing. And we can see that a is representing the first term, b is representing the second term. And then we want to substitute those in just utilizing our rules. So we know that we're taking our x to the third and we're subtracting. So it's our first term. We're subtracting our second term, and we'll just be squaring those. Again, when we'll be taking our first term, squaring it, minus our second term, and squaring it. Let's see what we end up with. So x to the third squared is x to the 6 minus our second term squared, which is 64. So the answer to this is x to the 6th minus 64. And it all kind of keeps coming back to that rule where it is your answer will be, back to that rule for a second. Come back to your rule, it is a squared minus b squared. All right, I want you to give it a try. Why don't you press pause and let's see how you do. Let's find a simpler form of each of these products.